Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength of materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 3, question 2. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP exams and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. This is combined bending and twisting of shafts. The question states, a solid shaft is supported by two bearings which are 1.2 meters apart and is used to drive a shaft with a flywheel and a pulley on the shaft. The weight of the shaft is 600 newtons per meter. The mass of the flywheel is 100 kgs and is mounted 800 millimeters from the left bearing. The pulley is mounted 400 millimeters from the left bearing and transmits power by a belt drive. The tight side tension in the belt is 2000 newtons and the slack side is 600 newtons. The effective diameter of the pulley is 400 millimeters. Assume the belts are vertical, downwards and parallel. Calculate each of the following: the reactions of the bearings, the maximum bending moment that occurs at the pulley, the maximum torque transmitted, the minimum shaft diameter if the principal stress is limited to 70 megapascals, the diameters of a hollow shaft made of the same material if the inside diameter is 50% that of the outside diameter, and also finally the percentage saving in weight if a hollow shaft is used. Now, what we're going to do is draw our shaft. There's our bearings at the ends of the shaft. So this is LR and RR. And between the two of them, 1,2 meters. Now, from the left hand bearing, 800 millimeters will be somewhere along here. This is the flywheel. So that is 800 from there to there. From there to there is 0,8. Right. And from here, I would put it if it's 0,8. If it's 0,8, I'm going to put the 0,8 here. Now, over here at 400 is the pulley. Next, we're going to put all our values to the right hand side. Okay. The flywheel, the weight of the beam is 600 newtons per meter. The weight of the flywheel is 100 kgs T1 is 2000 newtons. T2 equals 600 newtons. And yes, we have all our information that we need, because we need to work out our left hand side. So LR times 1,2, because we're doing this, if you will remember, doing beams to get our reactions at our supports. Clockwise equals anti-clockwise. So this is clockwise, it's going that way. So LR times 102 equals, now everything is going down this way. The pulley, 1,2 minus 0,4 is 0,8. So now the pulley is 2,600 times 0,8. The reason it is 2,600 is because we have to add both tensions. We're adding both tensions. Now, plus, now we're going to do our flywheel. That is 0,4. So our flywheel is 100 times gravitational acceleration equals 981 newtons. So 981 times 0,4. Now we do self-weight plus bracket 600 newtons per meter, so 600 times the full length, which is the self-weight, which is 1,2 times 0,6. What we're going to do, 2,600 times 0,8 plus bracket 981 times 0,4 plus 600 times 1,2 times 0,6. LR equals 2904,4 divided by 1,2. LR divided by 1,2, and we are left with 2420,333 recurring newtons. LR equals 2420,333 recurring. Let's get the right hand side done. Right hand side is not difficult. Right hand side, so RR times 1,2. Now from here to the pulley, now what we do is take 600 times the effective diameter, the slack side times the effective diameter times half the effective diameter. Okay, and M equals 920,133. 920,133 Newton meters. Next we're going to calculate torque, the total torque. Torque total equals T1 minus T2 R. So how we do this is T total equals 2000 minus 600 times 0, 2. So this is 280 Newton meters. So our torque is necessary for the next section. 280 Newton meters. Now we need to find out our minimum shaft diameter if the principal stress is limited to 70 megapascals. So ME equals 0,5 times M plus the root of M squared plus T squared. So what we have here basically is we need M torque is 280 squared. And our answer is ME is equal to 940,963 Newton meters. So ME equals 940,963 Newton meters. Okay, now we're going to get the diameter. Now we've worked out that, now we've worked out ME, now we're going to work out the diameter. Alright, now ME is also equal to pi d cubed stress over 32. Let's manipulate formula. We're going to manipulate formula to get d by itself. So how we do that, let's say ME times 32 equals pi d cubed stress. So pi and stress go down below, pi and stress go down below, and we're left with d cubed. How to solve that little problem is we cube root this. So ME times 32 over pi cube root equals d. So all we have to do now is just plug in our values. So ME 940,963 times 32 all over pi times 70 times 10 to the 6. Cube root of that gives us d, and that will give us exactly 51,4 0.542 millimeters. That diameter works only with 70 megapascals. Now we're going to work out the diameters of a hollow shaft if the smaller diameter is 50% of the larger diameter. The smaller diameter is 50% smaller than the larger diameter. So, let's go. ME equals pi times d to the fourth minus small d to the fourth stress over 32d. Now, what we're going to do is put our values in, because that's all we can do. Right, this is 940,1963, and that's pi times d to the 4 minus 0.5 to the fourth d to the fourth That's very important. Don't forget to say to the 0.5 to the fourth power. That is extremely important, because little d is equal to 0.5d. So where I put this, I had to say, so if this is that, then this is equal to that. So 70 times 10 to the 6. All over 32d. Now, what we're going to do is take 1 minus 0.5 to the fourth power, and that equals 940,963 equals pi times 0.9375d to the fourth power. 70 times 10 to the 6, all over 32d. Alright, so the next step, 940,963 equals, take all of this and keep your d, 6,443 times 10 to the 6 d to the power 4 over d. Now what we're going to do is delete the d, and we've got d to the power 3. So we have 940,963 divided by 6,443 times 10 to the 6. The root, cube root equals d. So shift the cube root of 940,963 over 6,443 times 10 to the 6. Equals, now d equals 52,667 6.62 millimeters. Now little d is 50%. If we will remember, little d is 50% of big D. So times our 0.5, we have 26,331 millimeters. That is our diameters of the shaft. So big D, 52,662, little d, 26,331 millimeters. Okay, now they want the percentage saving in weight if the hollow shaft is used. So what we need to do is calculate, we take the first measurement that we made of the most effective diameter at 70 megapascals. We take that one and we use these ones that we've just made. So what we're going to do is say, okay, this is the formula we're going to use for the percentage in weight saving. So this is 51,542 squared minus 52,662 squared minus 26,331 squared all over 51,542 squared, and finally that equals 21.71%. You're saving 21.71%. If you found this video helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.